Hello guys, in this video we will be covering about comparison of JavaScript objects. So let us start with the video. There are no good ways of comparing two objects. Whenever you use the double equal to or triple equal to operator, they only compare the references of the objects. References can be understood as memory references or memory address of the object. Only primitive types are compared by values. Okay, so here we are trying to compare reference types by values. You can see the person object 1 is a reference type, person object 2 is also a reference type. They are holding the same key value pair, but they are located at different locations in memory. Okay, whenever you are trying to create a new object, it gets allocated a different chunk of memory than the one the other object has. So these two objects definitely look identical to each other, but they are not at the same location. You are getting different memory location for these objects. So person object 1 can be supposed to be located at a memory location of 0x100. The person object 2 can be supposed to be located at a address of 0x101, and therefore if you try to use the triple equal to comparison, that will return true. Okay, but when you try to do the double equal to operator, then that will return false. Okay, so the two objects can have the same key value pairs, as you can see here, but they cannot occupy the same location memory. They are located at different chunks of memory. Okay, or they cannot occupy the same reference. The object is only equal to itself, as example shown below. So next we proceed to cloning or copying. It's another hard aspect of the objects. Whenever you use the equal to operator on an object, you are merely copying the reference. Okay, so let us see this by an example. An example you can see on the screen. Here we have a person object 1. It has a key value pair of name and it has a value of Pratik. So if I'm trying to assign the person object 1 to the person object 2, here what does this mean? So as you can see, we are creating an object, person object 1. When we say object person object 2 assigned to person object 1 is getting assigned to person object 2, so person object 2 doesn't get another new object with its own key value pairs. Okay, rather it start pointing to the person object 1. Okay, this is the core difference between shallow copying and deep copying. So in deep copy, you would get another object with its very own set of key value pairs having the same value as the original one. So let us see this with a diagram to understand it very thoroughly. So as you can see in the diagram, I have a diagram here showing the shallow copy and the deep copy. In the deep copy, you can see we are getting another object. Okay, when I say person object 1, it is pointing to some memory location which is 0x201, and it holds the key value pair name Pratik. Person object 2 is also pointing to a memory location that holds exactly the same structure that is being held by 0x201 memory location. But what is the differences? These two objects have their own independent existence. Okay, and that is what the deep copying means. And in case of shallow copying, whenever you create a person object 2 and you are assigning person object 1 to person object 2, person object 2 becomes a new reference that will point to this memory location. So here person object 1 was holding name as Pratik as a key value pair. When you assign that to a person object 2, you basically handed over the reference to person object 2 as well. So person object 2 is also now pointing to the same memory location as being pointed to by person object 1. This is the case in shallow copying. Okay, so let us proceed further. Now, how to do a deep copy? There are multiple ways that we can do a deep copy. The very first way is to use the spread operator. The spread operator is the same triple dot 3 dot syntax to a top level deep copy. As you can see on the screen, there is a person object 1. It has a key value pair, name is set to Pratik. Then it has a nested object. Nested details holds another object where address is assigned to earth. Now when I try to do a deep copy, a top level deep copying using the spread operator, I will say a new object, and I'm copying the key value pairs of the person object 1 into a new object, okay, and that will create a new object for me, which is person object 2. And in the deep copy we get a separate object as I showed in the diagram, okay. It is not referring to the person object 1, it has its own independent existence. However, this case is only effective for top level primitive properties when you are using the spread operator. In this case, the person object 2 get its own name property, okay. However, the nested object, which is the nested details, is still copied shallowly. That means whenever you define a nested object within an object that you are copying deeply, if there is some nesting, those nesting objects will be copied in a shallow manner, okay. But the top level primitive properties will get copied in a deep manner. That is the key crux of this. Also, if the value of a property is a function, then you cannot create a copy of the function reliably in JavaScript, as the function and methods have to be shared, okay. So let us proceed further. Moving on, we have another method to do a deep copy. We can use the JSON.stringify, and to use this we take a JSON representation of an object and parse it again to create another object with the same key value pairs. This has the nice property that nested objects are also deeply copied in this case. So whatever limitation we had in the spread operator, this is getting completely eliminated in the JSON.stringify case. So there is a drawback for this as well, is that the keys whose values are undefined, or the functions or symbol, they are script in this case. So moving on, we have another method, object.assign. This assign function will take a source object, which is the object 1 in this case, and a target object. It copies all the enumerable own key value pairs in the target object from the source. So from the source object, which is the object 1, I'm taking all the key value pairs. Then I'm assigning it to the target object, which is defined as the first parameter of the assign method. So a new object gets created, that is our target object, and that gets finally assigned to the object 2. In this case, the source object is object 1, which is the defined as the second argument, and the target object is an empty object. And just like the spread operator, assign doesn't copy deeply all the levels, okay. It copies the top level properties, but the nestings are copied in a shallow manner, okay. So that's the crux about object.assign. So in the next video we'll discuss about more properties, how we can use this concept in arrays, in functions, and we'll conclude with that. So if you liked the video, please give it a thumbs up and do subscribe to my channel. Show me some love, guys, and I will see you in the next video. Thanks a lot, guys.